Okay, guys. Here we go. Like I said, I do need time to get through this one. So, here we go. Yes, I. You get the notes? Yeah. Okay, is there a way you can come back?
I can't because I have to work it today.
Okay, that's fine. Yeah. Well, who else missed notes? Is Corey? Okay. There's Corey's. Okay, you get the calendars by the way? Yeah. Okay. All right, you guys. Here's the deal. There are 7 slides I'd like to get through because then you're good to go with your homework. Okay. This is the start, guys. This is the start of what I consider the hard part of chapter 10. So this is where your eyes and my eyes, we need to be together. If I mess you up, you don't understand what I said, put your hand up and just say, stop. I don't get what you're saying. Re-say that again, or just state it over again. I'll try my best, okay? Now, if you're with me day after day, we're going to be okay. If you miss class, I'm recording your class every day, I think. So I'll put these on, like I said, I'll Google it to you, I'll share it, and you can listen to it later, okay, in case you are gone from class. All right, here we go. You are going to now enter the conic section of chapter 10. Now in the conic section, we talk about parabolas. We talk about, we don't even talk about circles, to be honest. We already did in chapter 1. We're going to talk about the ellipse, and we're going to talk about hyperbolas. Now, where do these come from? They talk about this double nap cone. Think of an ice cream cone, one turned upside down. They meet right at the point, and they lie them on top of each other like this. And then what they say is this: to form a parabola, all you do is you cut this double nap cone. You cut it with a plane, and it says cutting plane parallel to the side of a cone. Here is the side of a cone right here, right there. If I took a plane, think of a large sheet of paper, and I took it and I sliced it right through the bottom cone. I missed the top cone. On the outside edge of the cone, it would form a what? Parabola. That's how the parabola is formed. If I took another sheet of paper and I slid it this way, right through the top cone, and it went right through there, it would hit and it would form another parabola going that way. That's the outside edge of the cone that it would touch. Okay? Now, how are circles formed? A flat horizontal plane cutting through. On the outside edge, you'd get your nice circle because it's flat, it's horizontal. If you take the plane, now remember, when I say plane, a sheet of paper, and you angle it up like this, now you don't get a circle on the outside edge, you get what they call a what? Ellipse. It's a circle that was squashed, okay? It's a longer circle this way and a shorter this way, okay? All right, here's a hyperbola. A hyperbola is take a plane and vertically slice this thing straight down, right down. And if you did it, it would hit one cone this way, and it would hit one cone this way. So hyperbolas are parabolas pointing what? Opposite directions. Up, down, like this. This or this, or that or that. It's one or the other. Okay? Those are your conic sections. They are parabolas, they are ellipses, and they are hyperbolas. That's it. Today, it's just parabola. Okay? All right. You can see this a lot better, right? I can't see this very well up here, so that's what I'm asking. Yes? I got to see what you're seeing. Okay. All right. Got it. Okay. This is everything. This is the definition of a parabola. What is a parabola? All points P in a plane that are equal distance from a fixed point F, known as the focus. and a fixed line D known as the directrix. Okay, now watch this. If you look at a parabola, somewhere they call this point the focus. Somewhere they call this line, wherever it is, I can hardly see it, the directrix. That's the directrix. Okay. Now, I'm going to read it one more time to you. It says, all the points P in a plane that are equal distance from the fixed point F and the line D. They're the equal distance. So what they're trying to tell you is, if you pick a point on the parabola, x, comma, y, then this distance right there, call that D1, and this distance right here, call that D2. What do you know about the two distances? They're equal. Whatever point you pick, it doesn't matter. This distance and this distance must be equal for you to have a parabola. This is brand new stuff. You guys haven't heard this, especially Algebra 2. Algebra 2 has not heard this. Enriched Algebra 2, you might have heard this. Okay? There are a few things up here that I have to talk about, you have to understand, and that is this. Let's go blue. Okay. From the focus to the vertex, they give this distance a letter. The letter is P. So what is the distance from the focus to the vertex? P. Now, what is the distance from the vertex to the directrix? They also give it the same letter, P. So here's the deal. You see that distance, P, and that distance, P, equal distance. So that should tell you something about the vertex. Where do we find the vertex? Where is the vertex found if this distance is P and this distance is P? Right in the middle. So to me, I would write this. My vertex will always be equal to the midpoint between the focus and directrix. Period. So basically, if you are ever given the focus and the directrix, these two, you will basically say the vertex is dead center, the midpoint. Just get the middle. That's the vertex. All right? There is also an axis of symmetry right here. The axis of symmetry is always going to be what cuts it in half. So that's the axis of symmetry. Stuff you already know about, okay? Now, really quick, let me show you something with numbers, all right? If I throw some numbers at you, what if I went like this? Here's your parabola, right there. Okay. Here is your focus, right here. Now, if I tell you that and I go like this, 0, 3, there's a couple things I want you to tell me. What's the p-value? 3? Okay. Is it positive 3 or is it negative 3? Positive? How do you know? Because what? Because y is positive? Is that what you're saying? No, don't do that.
Can't have negative distance.
Can't have negative distance. That is true, but the p-value can be positive and the p-value can be negative. Okay, here's my 2 clues. Does the parabola go up or does it go down? It goes up. The p-value is positive. Here's the other clue. Start at the vertex. Go up to the focus. If you start at the vertex and go up, the p-value has to be positive. So, when will the p-value be negative? When the parabola goes down. Okay. Now, somebody give me the directrix. Where's the directrix located? 0, negative 3. 1, 2, 3. Right there, says Colton. Colton, you're right. That point is on the directrix, but that's not the directrix. The directrix is a line. And if it's a line, give me the equation to this line. Yep, there it is. There. The directrix is y equals negative 3. Now, the only thing I want you to say or understand is if I pick any point right here to here, any point on the parabola to the focus, call that D1, and this distance from here to here, D2. Tell me something about D1 and D2. It's going to be hard to tell me because it doesn't look it. They're supposed to be equal. Do they look equal? Not even close. Guess what, guys? My focus should be higher up, but I made this problem up. Okay, the one thing I want you to understand is the distance between focus and the parabola and parabola to the directrix has to be the same. That's the definition. Even though this is not drawn to scale and it doesn't look like that, it is. It's supposed to be. Okay? Can I move on? If you say no, I won't move on. Okay? Now, here's a slide that shows you a parabola pointing which way? Sideways, to the right. Okay, when parabolas point to the right, it's no longer x squared, it's y squared. So when a parabola goes right or left, it's y squared. Which means, you might want to say this. Y squared equals right, or y squared equals left. I'll tell you the difference in just a second. Okay, so this one is going to the right. How come? Because of the focus. Look at the focus. If you start at the vertex and you go this direction right here. By the way, what direction did I go? From the vertex to the focus, I went to the right. Okay, if I go to the right, that would mean the p-value. The p-value would be positive or negative. Yep. If it goes to the right, the p-value is positive. Okay? Now, the other thing, if I back up this direction, p units, I'm at the directrix. The directrix will always be, in this case, how will you write the directrix? What equals what? X equals. You will always say x equals, and then I'm just going to put a question mark because I really don't have any numbers to deal with right now. So x equals question mark. Okay? The axis of symmetry will always be, in this case, sideways parabolas. Always the axis of symmetry will be horizontal. Okay? So the axis of symmetry will be horizontal. Okay. Yeah.
I was wondering if I could go use the bathroom.
Yep.
Thank you.
Now, the only thing I'm going to tell you about this parabola right here. Let's just pretend this is the focus. What do we know about the p-value in this one? The p-value will be, say again, negative, or I could just say less than 0. That is negative. Just so you know that. Okay? Can I move on? This is all just talk, and I know how tired you guys look. Will, I know how tired you look. Maddie, I know how tired you look. But I got to talk to you, because if I don't, you'll never know what I'm talking about later. Okay? All right. This is, after we get done with this slide, guys, you are moving. Your pencil's moving quite a bit. All right? Here are 4 possible equations that you might get if the vertex is located where? At the origin. These equations only work when the vertex is at the origin. Now, see this one? X squared. That's when the parabola goes up or what? Or down. Okay? So up or down it will be x squared. When it goes up, look at the vertex. Where's the focus? Up here. So that's when the p-value is positive. It goes up. But when the p-value is negative, your p-value will be negative because if you look down there, there's your focus. When you go from here down to get to your focus, that's a negative p-value. Okay. Then you would use this equation because up and down parabolas. When you get right or left parabolas, then use this equation, y squared. Now, here's the vertex. There's the focus to the right. This is a p-value greater than 0, right? So that would be this equation with a positive p-value. This one would be this equation with a what p-value? P-value here would be what? Less than 0. It's got to be because you're going left. So p-value is less than 0, go left or down. P-value is greater than 0, go right or up. If it goes up, down, it's x squared. If it goes right, left, it's y squared. That's it. Use one of these two to write equations. And here we go. Now the problems start. Oh. Ready? Example. This example, they want you to do this. Find the equation of the parabola with a focus of 1/2 comma 0 and the directrix of x equals -1/2. Now, I'm going to tell you and everybody, please sketch these problems. When you get to your homework, sketch them. I'll let you know what I did. I did this. Every box stands for 1/4 unit. There. So when you see a box, think 1/4. So where would a focus of 1/2 comma 0 be? 2 to the right. Yep, you're right, Corey. And that would be here. There's F. There's your focus. And a directrix of x equals -1/2 would be what kind of line? Up, down, right, left? Up, down, okay. It has to be right there at -1/2. Straight up. There you go. I don't see a vertex. They did not tell me the vertex. Do you know the vertex?
0, 0.
How come it's 0, 0?
Because that's the p's have to be equal.
The p's have to be equal.
So
Okay.
it's not like-
So basically you're saying this p is 2 and this p is 2? Or whatever, half. Okay. I was kind of hoping you'd tell me the vertex is the midpoint. The midpoint is what you were supposed to say. Okay? So 0, 0 is the vertex. So here I go. I'll put vertex 0, 0. And now once I know it's 0, 0, I can go back to the previous slide and pick one of the equations. Am I working with this equation? Or am I working with this equation? Which one? Y squared. How do you know it's y squared, not x squared? How do you know it's going to the right?
Because the focus is
To the right of the vertex. Right. To me, it always does something like this. It always curls around the focus. It is going to the right. It is a y squared. Do not use this one. Use that one. Okay, to write this equation, I hope you understand equations always have x and y in them. So do not touch the y. Do not touch the... Oh. Sorry, guys. This is supposed to be what? That was supposed to be x. My fault. This is x. All right, in your equation, don't touch x, don't touch y. You need this number right here. You need p. Look over there at your graph. Do you know what your p-value is? Yeah, it's from here to here. P is 1/2. So with that p-value, I'll put it right in for p over here. 4 times 1/2 times x equals y squared. Y squared equals 2x, yeah. You are now done. You just found the equation that matches that information. You okay with that? Now, see this? It says graph the parabola. Graph it. Well, you know what? I don't know anything about my parabola except, here's what I really know. That's all I know. I only know this much. How am I supposed to graph my parabola if I only know one point? So here's what you have to read down here. You have to read the box. It says any segment connecting 2 points on the parabola and passing through the focus is called a focal chord. Now, here's a focal chord, just so you know. Watch. Pick a point on your parabola. Go right through the focus like this. Keep going. Hit this point. That's called a focal chord. That is not what I want you to grab. Not the focal chord. I want you to keep reading now. The focal segment perpendicular to the axis of symmetry is called the lattice rectum. Okay, that might be the last time I say that word to you guys, lattice rectum. I'm not going to say that. I'm going to say focal width. I want the focal width. Now what's the focal width? It's the focal chord that goes through the focus, happens to be perpendicular to the axis of symmetry. So you know what it is? It's right here. It's this point right there and this point right there. These are the 2 points I want you to graph. This is it. Just graph those 2. Now, I want you to ask yourself, do you know the x or the y of that point? I know you know one of them. Maybe what? Why? Because the focus is 1/2. Over 1/2, wouldn't this also have to be over 1/2 up how high? Yeah, this has to be a half. It has to be whatever the focus is. So it's a half over down, half over up. All right, so how are we going to get that y value? How are you going to get that y value right here? Put it in the equation. Look, right here. See this yellow box? Look right here. Substitute the x value of the focus, which was 1/2, into the equation to find 2 additional points. Those 2 additional points are right here and right here. So let's substitute them in. Here we go. Where's the equation? Right there. Y squared equals 2x. Okay, what am I plugging in? I'm plugging in the x value, 1/2. Oh, 2 times 1/2. Y squared equals 1. Move on over. Y equals, when you take the square root, what? Plus or minus 1. There are your 2 y values. And by the way, that should make sense. There were 2 points. One of them is 1/2 negative 1. The other one is 1/2 positive 1. Are you okay with what I'm doing? Okay. All right. Hey, look closely, please. See that distance from there to there? That's up 1. See that distance from there to there? That's down 1. So what is the focal width of your parabola? 2. How wide is your parabola when it goes right through the focus perpendicular to the axis of symmetry? How wide is it? 2. Does that make sense? That's it. That's all you have to do. I mean, you really, really have to understand the wording. What's the p-value? What's the directrix? Where's the focus? You have to understand all that. And that's why this is such a long day. Yeah.
Can you go back up so I can see how you got the equation?
Right here?
Yep.
Yeah, the equation came from y squared equals 4px. Why is it y squared? Because it points right.
Where did you
Okay.
get the 4 from?
The 4 is part of the 4 is part of the formula. It's always in the formula. Okay? Now, where did I get the 1/2 from? The 1/2 is the p-value. From 0, 0 to 1/2 is 1/2. Okay? Alright. Alright guys, let's go to the next slide, and I have to have you change it. I don't like this equation. So let's go y squared equals, let's do 4x. Let's not do 2x, let's do 4x. Okay? Alright, here's what I want. Given the parabola, you're given a parabola with this equation. So y squared equals 4x. Do you know anything right now about your parabola? Up, down, right, left. What? Olivia says right. How come why'd you say right?
Because the last one was y squared.
Because it's y squared. Why'd you say right though?
Y squared. Right?
Y squared is right or left? Positive. See that number? That's positive. It's going right. Okay? Now, do you guys realize right now this equation looks like what I gave you on the previous page right here? Isn't that true? This is what I gave you on the previous page, a couple pages back. So that is that. Here's what they want now. Find the what? Find the focus. Okay, where's the focus going to be? Well, you know what? Before I do that, can I ask you this question? Let's not do 1 yet. Let's do 2. Find the coordinates of the vertex. Hey guys, doesn't this look just like 2 slides back? This looks just like what I gave you. Every equation will start like this, but I did tell you every equation has a vertex where? Where did I tell you the vertex would be? At the origin. Right here, I said right here. All these equations have vertex at the origin, so you're supposed to be going, oh yeah, this is going to have a vertex right at the origin. 0, 0. Now, go find the focus. For you to find the focus, you should know it's going to be over here. But how do I find how far to the right it is? I have to find what value? P. Go find P. Now look close. See this 4 right here? Where'd that 4 come from? Right there. That 4 came from that 4P. So what I would do is I'd say, oh, well, 4P must give me 4. P must be what? 1. So the focus is really 1, 0 with a p-value of 1. Which leads me to believe the directrix is what? What equals what? X equals -1. There it is. Okay? Because the p-value is 1 this way and 1 this way. All right. What? Oh, I already did 3. Number 3 is done. I got it. It's right there. What's the focal width? Well, to me, the focal width is this. It's going to go that way and that way, right? The focal width, hey guys, just do a quick sketch of that. Don't do it really heavy yet. The focal width is right here. This point, this point. Now what do you know about those 2 points? Which value do you know? Do you know X or do you know Y? You know X. X is 1 here, so it's got to be 1 here and 1 here. Well, how do you get the Y value? Plug it into your equation. Remember your equations right here. Y squared equals 4x. So you'll let x be 1. You're just taking this number right here. Take the 1, stick it in. Y squared equals 4. Better yet, y is what? Plus or minus 2. When you get the focal width, you actually get 2 answers. One is -2, one is +2. Okay, there it is. Hey guys, to make this look a little better, I'm going to go like this. Here's 1, here's 2. I'm trying to draw it to scale. Here's 1, here's -2. There. Does that look okay to you? You know, I just want it to look like the numbers. 1, 0. 1, 2. 1, negative 2. Okay? And that's it. You okay? Can I move on? This is it. Last slide.
So we wouldn't write the focal width.
Oh, yeah, if they ask you for the focal width, do it.
Okay.
Sometimes they do ask you, Corey, and sometimes they don't. Since Corey said it, guys, what is the focal width? The focal width is what? 2 down, 2 up. It's 4. Yeah. So, I suppose, let's write it down. 4. Focal width is 4. Go to the next slide. See if you can tackle it on your own. Still got 5 minutes. I think we can get this one in. Okay, I'm not going to wait. The 5 minutes goes fast. Find the equation. Oh, is it this one? Or is it this one? Well, keep reading. Of the parabola with the vertex at 0, 0. Okay. 0, 0 is right here. And containing the point 1, negative 8 over 1 down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right here, right here. Do you know if this parabola right now goes up or down? Or right or left? Right now, do you know? You think it goes down? But it could do this, couldn't it? Could it go down like you said? But it couldn't do this? Go to the right? But there's a dead giveaway here, guys. Keep reading. With the axis of symmetry on the what? Y-axis. The axis of symmetry is right here. This is the line that cuts your parabola in half. Now do you know which way it goes? Colton said down, yeah. So it goes here to the vertex. This is the vertex. Hits it and comes down. This point must be negative 1, negative 8. This point is 1, negative 8. That's my quick sketch that I wanted you to do. It goes down. Which one you gonna pick? X squared. X squared is up or down. Do not pick y squared. It doesn't make sense. All right. So let's go get this equation. Hey guys, the only thing you need when you write equations is x squared and y. You don't need p. But you've got to get the p value out of this. How? How are you going to get it? Okay. Colton says, see that 1? That's just x. See that negative 8? That's just y. They're giving you xy. So let's put xy in. Here's x. 1, square it, equals 4 times p times y. Y is negative 8. 1 equals negative 32p. Divide by negative 32. What's your p value? Right there. So, to me, it says go down 1/32. That's hardly anything, guys. I'm not asking you to graph that, just that's where it is, though. That's the focus. Okay? How do you write the equation? You have to come over here still and write the equation. X squared equals 4 times the p value times y. What's that number in front of y? Negative 1/8. Okay. There it is. That is the equation to that skinny, skinny parabola pointing down. Right here. We made it, but just by the bell, okay? it's not like you really know this well. Do the best you can. If you can't finish it, you can't finish it. We got 3 days. I have graph paper if you want it. You want graph paper, it's right in Christian's hands. He'll give it to you, or put it on a desk, Christian.